Hi, everyone. It's Judy. Welcome back to the OnTrack podcast. Thanks for joining us again. Today, we have our friend Tomas Chester, who is the owner and hardware designer at Chester Electronic Design. This is part 2 of the podcast. In this one, we'll be talking about an amazing material library he's made for Altium Designer that you'll want to know about, and also be talking about his involvement in PCEA, which is the Printed Circuit Engineering Association. This is an area where I think you'll really want to get involved and join and hear about his latest time of launching his chapter in Ontario, Canada. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, hi, Tomas. Thanks so much for joining us again. We're glad to have you back for part 2 of the podcast.
Yeah, thank you very much for having me again.
Always great to talk to you. So what I wanted to talk to you about today was sort of a feature that's in Altium Designer that I don't think everybody takes advantage of, but we, I think it was a year ago, introduced a materials library. And so, as a design engineer that really is tapping into this feature, can you talk about what that is in Altium Designer? And then we'll talk about the materials library that you've developed for that feature.
Sure. So in Altium Designer, in Altium Designer 20, it was added, I believe. In the layer stack manager, you now have the ability to go in and look at a materials library. Altium by default goes and provides some materials in there for all of the variety of objects you might need, such as your dielectrics for your cores and your prepregs, but also other items like your solder mask, or if you're doing flex circuits, the various materials you could be using for those. And so you can access that through the layer stack manager in Altium Designer.
And if I understand correctly, if you're a design engineer, you can sort of self-populate that, right? Like you can actually build out your own materials library by putting in the data from, say, a materials data sheet, right?
That's correct. So you can go in and open up the materials library. There's the option to go and create new materials. And so you can add in each of the different materials and each of the different thicknesses based upon the weave or the tightness of the fiberglass, the resin quantity, and then also go and give it all the other details, such as the DK and DF values.
Yeah, which I think is a great feature. So you've done something, though, is taken some of the work out of that by creating really an open source materials library that lives on your website. So tell us a little bit about this materials library and what you've placed in there.
So I've been slowly getting different bits and pieces of information from a couple of different materials vendors. Some of the information is readily available on websites, and others I've had to kind of tap in through some of the sources and connections that I've got to talk to some of the vendors to get their materials details. Of course, not everything is getting shared, and that's perfectly fine. And if you're doing something extremely specific, I may not have the content that somebody needs. But what exists within there currently is the majority of the Isola product line for their dielectrics, so prepregs and cores. And I also recently, at the end of last year, finished up entering all of the Ventec product details. And so as I kind of go through, I slowly update it over the course of the year and add in a document that goes and shows this is what's currently here. It lists all the different materials from the vendors, but then it also goes and has the additional details of what I'm working on and what's coming up next. And that way, if somebody's interested in something or really needs me to add something in, they can reach out and let me know.
Which is great. So for our listeners, we are going to share the link directly to Tomas's website, but also the link that goes directly to the materials library. And so it's just basically a plugin, right? You can take those files and load them into Altium Designer, or how exactly does that work, Thomas?
So on my site, there's a link to the FTP where you can download the file. It's a compressed zip file that has inside of it 3 documents. One of the documents details the materials that I currently have in. That way, it doesn't take you any time to go and check if the material you want to use is there or not. The second is another PDF that details the instructions on how you go about installing this materials library. Because to do this, you have to enter into Altium, open up that layer stack manager, go into the materials library, and then tell it to load. And then the third file is a XML file, which contains all of the contents and the details of the materials library and has all of the various properties for all of the materials I've entered, which you can open up and look in a text editor at, but it's a lot easier to view if you open it into Altium Designer.
Excellent. I love that you've put the instructions in there and made it easy. So again, for our listeners, we're going to share both those links below, and then you can take advantage of all this laborious work really that Thomas has done, which we really appreciate. Thank you so much for doing that. Really, as just a act of goodwill. That's very valuable for you, but also for the Altium Designer community. So thank you so much for doing that. So thinking about this materials library, again, I think it's an area that isn't always taken advantage of, which is easy to do in software, particularly in Altium Designer, as we keep adding these features, but you just sort of have your workflow, right? And you do it in a way that you've always done it before, right? And so when you were thinking about this materials library, kind of what motivated you to want to populate this, and what's the benefit to accessing this particular feature in Altium Designer?
So I started putting the data into this library for kind of a few different reasons. One of them was I wanted to ensure that the final stack up that I was generating would have the accurate materials representing that circuit board. There's also a lot of tie-ins within Altium Designer when you start creating your layer stack up, either in your design views inside your PCB doc, or if you do it in Draftsman. And what it does is it accesses that layer stack manager and takes the details from there. Well, by default, because there's no real properties in there, it doesn't populate that table with any of the right contents. And so I wanted to ensure that if somebody was designing something, they can at least get roughly the right materials in and be able to have that auto-populate and generate in the various areas that they might be using it. But the other area I wanted to use this for is you can utilize it and it transfers over into the 3D perspective view of your board design. And so if you're doing a board design that's, let's say, 20 layers thick, or even a board design that's 4 layers thick, you can then take it and you can see the various different stack ups that's occurring, and you can see the spread, like here's my copper at the top and what's my gap distance down to my next material, and then, oh, I have a massive gap in the middle, or I have a tiny gap in the middle. And it gets visualized in the 3D viewer based upon this information that you're pulling in from that materials library.
Sorry, go ahead, Thomas.
The final addition as well into all of this is it ties back into the layer stack manager with the impedance profiles that you can go and generate. And so the 3D field solver that's embedded within Altium Designer relies on this information to be able to properly calculate impedance details. And so once you start creating your impedance profiles and information in your layer stack manager, that information is now accurate. And sure, you can go and solve this outside, or you can contact your PCB vendor to go and do this for you. But it enables you to take more control over the design yourself and see the impacts of what you're doing.
I think that's a real benefit. Again, coming from the board fabricator side of the world for so long, most of the customers do depend on the board fabricator to do that. But if I were a designer, I think I'd want to have a little more control and just feel good about it before the handoff. But I guess it's a matter of personal preference there. But I would think you'd like to have that.
It's definitely useful to have. I mean, with any design that you're doing, you should try and be in constant communication with your fabricator anyways, just to
Absolutely.
ensure that what you're actually designing can actually be built. But it definitely does give you some additional control, and it also furthers your understanding of not only how your board is fabricated, but what options are available to you. If you're suddenly trying to change your impedance stack up and you're using a very specific material, you may find that a thickness that you need simply just doesn't exist. And
Mm.
instead of having to ask that question and wait for a response, you can quickly look inside the materials library and go, okay, this isn't going to work. What do I need to do to fix this in my design? Because I can't fix
Mm.
this with my layer stack up. I have to fix this somewhere else in my trace routing or some other way.
Interesting. And so the field solver for our listeners, the field solver that he's mentioned that's embedded in our tool, is a physics-based model that's put out by Symbior, which is the actual tool is called Symbian. And I know that our R&D team has worked closely with their team to actually embed that. That is really physics-based. It's a lot of heavy-duty math. So again, something that people are just beginning to tap into, but not all realize how powerful that tool that is actually sort of baked into our engine now. So I think that's a really cool benefit. And we're going to keep adding more features like that relative to simulation that I'm personally excited about. I think it gives a little bit more depth to the ability to simulate in our tool. Well, we're excited. I'm like I said before, I'll make sure and share those links below. Make sure you guys go over and grab those because I think it'll be a great benefit to you. So let's transition here, Thomas, and talk a little bit about PCEA, or Printed Circuit Engineering Association. You and I have both been involved in that organization that was just designed, and particularly has been relevant as we've been shut down during COVID. But they were really meant to be live in-person meetings where regional printed circuit designers could get together, have mind share, get social, share ideas, and just get better at their craft. But COVID sort of turned it to this virtual environment. So tell us a little bit about PCEA, their mission, and sort of who's it for, and why is it there?
So PCA is basically targeted for anybody in the PCB design industry. It's meant for both your engineers who are designing your schematics, your PCB designers, people who are possibly doing both jobs, but it also goes beyond that into the fabricators, the assemblers, the material suppliers. It's meant to be all-encompassing, and the reason for that is to assist with addressing the challenges that exist within our industry. One of the big things that it's there and intended to do is to assist in the collaboration and education of people in the various stages of the industry. Yes, I know how to design a printed circuit board, but I'm not an expert on how to actually put the laminates together or make sure that the copper thicknesses are correct, or ensure that when it gets placed through my SMT line, all the components are placed in the correct orientation. There's a lot of facets to designing a circuit board that extend just beyond the use of CAD software. And so it's here to try and bring those different groups together, and also then to inspire them and educate them and bring the knowledge to the forefront, and set it up so that we can assist one another in improving our designs and making sure that first design spin is the design spin that works.
In the past, I was involved with the IPC Designers Council, which that program was retired by IPC, and they're spooling up something else now that I think has been as PCB design, and I've had those folks on the podcast before, and so they're working on launching another program. So I think the Designers Council meetings of the past. The PCEA is sort of filling that place right now, and it included, the ones I was involved in included a speaker. So to your point about the different stakeholders being involved, you might bring a fabricator or assembler or it's just anything from that supply chain that would help designers know how to design and be successful, right, in those handoffs, or via structures, or so many different. And so it was bringing in really good talented people, and I know because of the wonderful people that are involved in PCEA, they'll be pulling in some of that same talent, right, to do kind of like webinars, but it'll also give you the opportunity to be social, if I'm correct. Is that your understanding?
Yep, it's giving a chance for definitely for people to be able to meet and to share. But what's also happening there is we're trying to empower people within the chapters, the members. If you have something that you think is interesting and worthwhile and you want to present, it's not just for the industry experts or the owners of companies or people who understand what's going on. If you have something you feel is of value and you want to share that with your chapter, but also then possibly take that to a larger stage, it's there to empower you as a member to get more exposure, but also to push through and bring what you feel are important ideas into the industry.
Which I love that idea, right? Of you guys, feet on the ground, sharing your learnings with one another. So it's a very good point. Thank you. So recently, you are going to head up the Ontario, Canada chapter. And recently, you had a Tri-City kickoff in January with your chapter, Ontario, Canada, as well as the Minneapolis, St. Paul chapter, and also a chapter in Michigan. So can you tell us a little bit about how that kickoff went and, what things you're looking forward to?
That kickoff was an amazing time. It was a little bit different because we were having 3 chapters all starting together. Typically speaking, we have a little bit more of a socialization time at the end of our kind of presentation. But due to having kind of people from different regions and the numbers we were having, we decided that the better choice would be to have a panel discussion. And so instead what we had was the panel discussion, including our sponsor, Advanced Circuits for that, who's a sponsor of the PCEA and a generous sponsor of that webinar. But we also then had the chairmans of each of the chapters in and had a good conversation about a variety of different things in the industry and why the PCEA is here and where we're seeing things going in the design space and within the fabrication space.
Mm-hmm. Yeah. So how many people did you end up having attending, do you know, for the kickoff?
Now, I believe we were close to about 35 to 40 participants. So it was a good number to come out. And yeah, we want people to spread the word and kind of grow this, but it's not just limited to these chapters. There are other locations that you can go and have a look at. So feel free to go and kind of investigate and explore the PCEA website.
Yes, and I'll be sure to share those links below for our listeners to PCEA, and you can kind of poke around and see what's available to you there. And also, the membership is free, or they're looking also for just voluntary donations that, of course, help them to manage their operating costs. So what personally motivated you to join? And if, say, you're speaking to our listeners here, what do you think the benefits to them are besides, say, the education, that you hope to fuel within that community?
I got involved because education was a big aspect, but it was also wanting to reach out and connect with the rest of the industry. One of the nice things is on the PCEA website, there is a bunch of free resources there that you can look at that explain and give you access to a variety of things, but also wanting to kind of connect. I've had a lot of past experiences where some of the training events end up being more of a sales pitch and less of a training setup. And so it was nice to kind of get into an area where instead of having a salesperson talking to you, you're talking to somebody who understands the challenges you're going through, probably has dealt with them, a bunch of them themselves.
Mm-hmm.
And you can relate with that person and not only just talk about the actual educational aspect of what you're trying to learn, but you can also theorize and go outside of those bounds and explore and be social and laugh about things that I know when talking to others sometimes they don't understand what I'm talking about when I talk about designing a printed circuit board. They're not in that industry. They're busy doing something else. So you have that ability to connect and talk to other members who get what you're doing.
I think that's a really big piece. There really is a community aspect where you get to speak the same geeky language together.
Mm-hmm.
And also share great ideas. You may have something for them, they may have something for you. And I think there's real value in sort of, getting to know someone. You had talked about something you've sort of embraced, which you've mentioned is question, answer, and explore. Can you tell us more about that?
Sure. So this goes back to learning, and I think all of us throughout life are trying to learn from our experiences and become better at what we're doing. This applies to electronics, but it also applies just to life in general. So question, answer, explore, ask questions. You want to understand what's happening, whether it's in your workplace, within the designs that you're doing, within relationships that you have. Ask those questions so that you can understand. Communication is a big aspect of our lives, and even more so now that some of us are currently locked down at homes and others are just restricted in our access to go out and do things. And following on from that is answer. You've asked the questions, you've received knowledge, but you also want to go ahead and share that knowledge with other people as well.
Mm-hmm.
You want to pass that along to other people, but answering isn't also just about that. It's also about reaffirming that the answer you received to your question you properly understood. It's just like when you meet somebody, you try and say their name back to them so that it helps you remember their name. In the exact same way, you want to also answer other people's questions so that you can reinforce and embed that knowledge that you've gained and be able to put it into your own words that you understand. And then finally, explore is going above and beyond both of those. You're gaining knowledge, but don't be content with what you have. Expand outside of that and look at new ways to use your design tools or new ways to solve problems. Maybe there's a new technology or board design strategy or fabrication method that can reduce your costs or make something that was impossible to design before now possible to design. And if you're not exploring and investigating what's going on out there in the industry, and not even just within our industry, but adjacent ones or even other ones that aren't even related, you might find solutions to your problems that you didn't know were out there.
I think that's really valuable, particularly in these times, because we are so detached and we've all lost the ability to go to, trade shows or meetings with each other or just even talk around the water cooler. I think it's something we really lost in these time of lockdown, and communication has become even more problematic than it was before. So
yeah, those water cooler conversations or the quick conversation in the hallway that suddenly turns into 2 hours in front of a whiteboard understanding a concept or trying to solve a problem. It's really hard to do that now when you don't have contact with your coworkers or people even working on the same project, or even partners or other companies that you're relying on. There was a lot of interfacing that was available there that now is having to be done in different methods. And in some ways we've gained some things in terms of connections, but in others we've lost those spontaneous moments that help us share and learn.
absolutely. Well, again, congratulations and kudos for you for starting up the Ontario, Canada chapter. And I think this is wonderful that you're sort of helping fill this fill this need right now during these challenging times. And I'm sure you'll continue to do so once the world opens up and get to do some of these in person, which will be way more gratifying, I think, for all of us.
Mm-hmm. I know some people that I'm talking to are having some of the difficulty because they feel like they're talking to the wall a lot and they're missing that human interaction. So it'll be great when things get back on track and things open up again with the vaccines and everything that are coming.
Amen to getting on track. On track with human relationships. I think we're all ready for some of that. Well, Tomas, thanks so much for joining us and offering these wonderful resources to our listeners. We always appreciate everything you do to contribute to the engineering community.
Thank you very much for having me.
My pleasure. For our listeners, again, make sure you check out the show notes. We'll share everything that Tomas has shared below, and we will also share the links to PCEA and how you can get involved there. And we thank you so much for joining us today. We'll see you next week. Until then, stay healthy, stay safe, and always remember to stay on track.